No matter how backward your engine technology is, as long as you use turbocharging, the power gap between you and the top engine will not be too large. Turbocharging is the equalizer of all beings on the engine. Today is the fourth issue of the engine series, explaining the structure principle of turbocharging in detail. The boss helped to give a like, and we began to talk about it. The biggest factor affecting the power of an engine is actually the amount of air intake. Because fuel needs enough air to burn in the engine, there is an optimal air-fuel ratio, 14.7 kilowatts of air ratio, 1 kilowatts of fuel. Only the more air enters the engine, then the fuel injector can spray more fuel. The heat generated after mixed combustion is more, and the power converted is stronger. In the era of natural suction, if you want to increase the intake volume of the engine, you can only increase the cylinder volume of the engine, so that more air can enter the cylinder, that is, increase the engine displacement. But making the cylinder volume large, it also has disadvantages. It will make the engine larger, expensive, and the fuel consumption in the urban area is also very high. So there are no martial arts, ethics superchargers. Some people say that a supercharger is similar to a hairdryer, but it is not. The core function of a supercharger is to suck in air and compress it to make the air smaller and denser. If the cylinder volume of an engine is 0.5 liters, it means that it can only hold 0.5 liters of air. If it is a naturally aspirated engine, it can only inhale 0.5 liters of air at atmospheric pressure when it inhales air. If it is a turbocharged engine, its supercharger effect is 50%. It can compress 0.75 liters of air into 0.5 liters of volume, and then send the compressed air into the engine cylinder. The same as the cylinder volume of 0.5 liters, but it sends 0.75 liters of atmospheric pressure air. Since more air was being fed in, more fuel could be injected according to the empty column than the fuel injector, and the power of the engine would naturally be stronger. Naturally aspirated and supercharger models were, like ordinary biscuits and compressed biscuits, eating the same amount, but the energy obtained after eating compressed biscuits was obviously higher than that of ordinary biscuits, and this supercharger required energy consumption to inhale compressed air, so it couldn't work on its own for no reason. This supercharger has two different driving methods. One is turbocharging, and the other is mechanical supercharging. Let's talk about mechanical supercharging first, which is directly connected to the crankshaft of the engine with a belt. As long as the engine starts, it runs with the supercharger, and its supercharging effect is directly related to the speed of the engine. If the engine rotates fast, the supercharging effect will be better. The advantage is that it keeps the natural suction smooth and linear, but the disadvantage is also obvious. That is, it will increase the load of the engine, and part of the power of the engine will be divided by him, which will lead to high actual fuel consumption. If you want to improve the power of a naturally aspirated engine and don't care about fuel consumption, you can add a mechanical supercharge. Like Honda's self-priming fit and the early naturally aspirated Toyota Prado, many people will modify and add a mechanical supercharge, but there are certain risks in the modification. The engine output power increases, but the cooling system and engine material may not keep up, which can easily lead to shortened lifespan, and the original driving computer may not match. It is not recommended for beginners to modify. And another turbocharger is also the most popular type of engine now. Its supercharger driving force is the exhaust gas emitted by the engine, so the full name is called exhaust gas turbocharger. It consists of two parts, a supercharger and a turbine, which are connected to the upper level through a shaft. At the exhaust end of the engine, the exhaust gas discharged impacts the blades on the turbine, causing the turbine to rotate, and then the turbine drives the supercharger through this shaft. What determines the supercharging effect of a turbocharger is how much exhaust gas the engine produces. For example, when driving at low speeds in urban areas, because there is less exhaust gas produced, the force of impacting the turbine blades is not enough. It is not that it does not rotate, but it rotates very slowly and the pressure is not enough, resulting in the supercharger having no supercharging effect. The turbocharger in our family car generally requires the engine to be between 1,400 and 2,000 revolutions per minute in order for the supercharger to have a supercharged effect. That is, the turbocharger starts to work. So some cars will feel a little bit of instantaneous impact between this speed. Of course, the most important thing is turbohysteresis. Many people don't understand what turbohysteresis is. You want to accelerate and step on the accelerator, but his power does not follow immediately, but has to wait for the engine to increase the speed first, produce more exhaust gas, and then the exhaust gas hits the turbine, and then with the supercharger to increase the supercharging effect, the supercharger will send higher density air into the engine, and then the power comes. This process will have a delay of 1 or 2 seconds, 2 or 3 seconds, and this delay is the turbo pool quality. The larger the turbo used, the better the supercharging effect, the stronger the power, but the same turbo pool quality will be more obvious. For example, in the Ford Mondeo 2.0T engine, the power can be said to be ceiling level because the turbo tank volume he uses is large and the supercharging effect is good. Many people say that his slow throttle is due to tuning reasons, but in fact it is more the reason of this turbine. Now the boss must be very familiar with engine superchargers. We will continue to talk about why turbocharging can save fuel in urban areas, provide power at high speed, and don't forget to pay attention to